Yeah, so today's presentation is based around common site issues. So as Adam mentioned, um, yeah, I've been with Prider for about 19 years, so in various different roles and seen a lot of building issues on site. So today's presentation is really about fleshing out some of those common site issues and looking at ways to try and rectify them and getting ahead of the curve so that these issues don't become a problem on site. So I'm the engineering manager for Prider, and my real key role function is to promote and educate efficient engineering design and compliance requirements for our customers and their builders. So who's Prider? We're basically a part of the ITW network, which is a network of familiar building brand names, which you've probably likely come across during some stage. Our core market is really timber, roof and floor trusses and wall frames, and our business is really engineering design software, technical support, frame and truss manufacturing equipment, and we also supply a range of timber connectors and products that go into the DIY market and for builders' projects. So as I mentioned, today's presentation really about those common site issues and ways to try and prevent them. And first up is probably the number one request that we get through our design services team is mechanical services units. And it's a little bit astounding because every modern construction these days has got air conditioning units. So it's a little bit mystifying that these sorts of things are happening on a regular basis, but that's one of our most common inquiries, is to modify existing trusses that are already on site to fit these AC units. And in this digital age, I feel we should be doing a better job of this. So where this has come from is really the beauty of trusses is they're 95% air. It's very slender members, and there's lots of void spaces in and around the truss where these AC units can sort of typically fit. But as the design requirements, so you can see the air conditioning units sitting nicely in those void spaces in between the webs. As the designs start to move towards more shallow type roofs, you're starting to see these conflicts coming about with the shallow pitch is reducing that void space, and you need to sort of plan ahead for these types of units because they're actually, some of them won't actually fit into roof space. We've actually had a couple of jobs where trusses have gone to site and the builder said, I need this air conditioning unit in there. It doesn't physically fit into the allowable roof space. So you need to plan ahead. And the beauty of the software and the program is if you do plan ahead, you can actually create these void spaces in the roof to easily fit these units in. So here you can see a typical type of rectification request that we get. The trusses went out to site. Oh, by the way, we need an air conditioning unit in here, shallow pitch roof. It needs to run across these three trusses. So you have to cut all these trusses off, put beams in between them, and then stiffen the trusses up on either side so that they can take the additional load. So a lot of site work and issues created. So everyone has to stop on site. Any scheduled works you have to sort of reschedule so that you can do these rectification measures. So this can all sort of be resolved by having appropriate planning for these types of units on the detailing plan, so the fabricators can design around them. So again, you can see the system sitting up here with the in the unit here. They've had to basically cut all this through with the beams, and you have to allow for the ducting units as well. That's the other critical thing, is that it's not only the unit itself, it's the ducting that runs off these units that needs to be taken into consideration. And it all gets exponentially worse when you've got steel ducting. So normally you got in residential roof spaces, you've got flexi ducting, so you can work them around some of those open areas. But when you've got steel ducting, they're pre-formed, pre-made. You don't have the luxury of being able to move them around on site. So you have to design the trusses around these particular mechanical services. As you can see here, the roof truss software has the capability to set parallel girders, create these void spaces for these AC units, but it has to be known at plan stage. Okay, and why this is really critical is it becomes hard for the engineering team to be able to site modify these, because a truss is a really powerful mechanism for distributing loads out to support. So you can see here they rely heavily on what's called triangulation. So once you remove a web, you can see this web has been taken out. So there's an AC unit going to be put into this space. It loses its depth and its stiffness, which the truss relies heavily on to be able to perform to its peak. So as you can see here, the loads will come down through this web up to this one, and then it goes down to the support. In this case, where the web's been removed, it'll come down to this web, up to that one, and then, there's nothing here. So what happens is the truss tends to deflect exponentially. So when this web's in place, you can see the deflection on this design is 1 mil, which is, the truss is performing beautifully. You remove just that one web, and all of a sudden you've got 127 mil of deflection at this point. Okay, so it totally throws the truss into a tailspin, and it becomes hard to work around those conditions on site, because you need to run beams, support beams, and stiffen the trusses each side. Similar sort of attention to detail to skylights, another common issue. You can see here the detailer's done quite a good job. You can see the plan with these skylights in place, and the detailer's put the void spaces in and around the trusses. However, what they missed on the plans was this particular skylight had a raked light plan at the back. So there's actually a rake section across the back of this skylight that ran down through these trusses. And so again, it's that making sure those plans are accurate and reflect the details that are required to be designed around on site. Another common one, pipes and services for floor systems. So, waste for showers, those sorts of pipe works in and around the shower areas, common. And these sorts of conflicts can be set in the plans, and if they're not, you often have these issues on site where people drill down for the pipes and they'll run through cords and members of the webs, and they have to come through to the engineering team for rectification. So you can see here a weld ADAT plan. Okay, you can see the ducting voids have been run through the floor systems. The floor systems are critical because they're very shallow in depth, so they're very hard to run pipe work through there or ducting voids through there. So you need to allow them at the planning stage. You can see this type of layout. They've got AC ducting, they've got sewer stack allowances, and they've got duct voids all through the floor system here, which is the way you'd like to see your floor systems designed. And as you can see, the floor profile of these trusses actually creates the webs around the void to allow them to flow through the floor system. So the key points from this is making sure you've got accurate plans available to the fabricator at quote and detailing stage to avoid these site delays and expensive engineering and rectification charges. They can be easily designed around, but they've got to be on the plans. And similar for pipe work and services for floor systems. Make sure you have those conflict zones marked on the plans so they can be worked around. Parapets really becoming really commonplace. Shallow pitch roofs and parapet designs. A lot of people put these dwarf wall frames on the end of their parapets, which is a no-no. These parapets actually have to take a face wind load on the outside of the wall frame, and so you need a mechanism at the base here to be able to restrain the wall from tilting over. Okay, so simply nail fixing a dwarf wall frame onto the bottom cords of these trusses isn't a suitable mechanism. You need a moment resisting joint here, which we use a little plated frame that can be fitted in the factory. And so you need to make sure that those, you're not putting dwarf walls and parapets, because they can actually collapse, as you'll see in a minute. But here you can see a typical detail of a parapet frame. They can be manufactured on the truss, so they can be made physically on the truss, or they can be sent out as a separate L frame, and then these can be stitched and screwed to the side of the existing truss to form the parapet frame. And then you've got your moment resistant. If you don't have those, you get a high wind load. This is a storm that happened in Sutherland, and you can see, even though it's not a timber truss, you've got a brickwork frame coming up here, the parapet, there's nothing to support it. When those wind loads come on, it can knock the brickwork over. Internal wall brackets, one of my favourites. These have provided us with a number of headaches over the years, and it really comes down to the fixing technique on site. So what needs to happen is the truss needs to be able to settle on site. Okay, it needs to be able to deflect, and so the way that that's enabled is with these slots in these brackets, and the nails that are fixed through them slide down through those slots. Okay, so they have to be allowed to move. So the correct fixing technique is to fix the brackets to the center or the top of the slots. The nails should obviously be the Pryda 35 by 3.15 hand hammered nails. And what you need to be careful is with girder trusses, they may need to be renailed after the roof is loaded, because if you have girder to girder connections and another standard trusses coming off them, there may not be enough slot depth in some of these slots to be able to take up all of that camber dissipation from those connected trusses. They need to be fixed at 1800mm centres to the top of each internal wall, and any short walls you need to stabilise them at each end with one of those fixings. So they're really a lateral restraint for the top of the wall to prevent it from moving. What we commonly see on site a lot is these nails actually being fixed right at the bottom of the slots. And so what happens is the truss tries to move and camber, that locks onto those nails, and then you'll get a load pass through onto this wall, which causes cracking in the cornice lines. You might get shear cracks through the top of your bulkhead frames and your openings. You need to be really careful. So not at the bottom of the slots. Don't overdrive the nails. You don't want to be smashing these things into the steel, because you can see one of these is, you could dent the steel work and those nails bind into the brackets and prevent the truss from moving. And an absolute no-no is obviously don't use gunfire nails, because that'll just lock the bracket up entirely. And I've seen a lot of people use these brackets to support bulkheads, but because of the nature of the brackets, they can actually slide. And so they're just not a very good support mechanism for bulkheads. And so you can see a typical problem with cornice lines. What happens is when the truss moves, it'll tend to deform the bottom chord where this bracket is located, and you'll get this, differential settlement between the trusses each side and the truss with the bracket on it, and it'll cause this cracking and these separation cracks in the cornice lines. Is there a better way? Well, here we go. Here's the promotional part of the presentation. Yeah, so obviously we've released an internal wall screw these days, which is, fantastic innovation for us and I think for the industry. I won't bang on about it too much, but if you go and see our website, you'll see all the details on there. But really what this is a screw with a knurling slot in here. And as it drives up through the top plate, it cuts a hole for the screw, and the screw can slide up and down through that hole. So this part of the thread goes up into the truss bottom chord, and this keeps the wall laterally restrained but allows the truss to move vertically. And it's a lot faster and easier to install than the internal wall bracket. Girder bottom chord rotation, another one of my favourites. So girder trusses typically support really heavy loads from other incoming trusses. When a structural member is loaded outside of what's called a shear centre, which is for a symmetrical beam like this, is basically the centre of the axis of the beam. If it's not loaded there, it'll cause it to rotate. Okay, and the larger the incoming load, the greater the tendency for this member to twist. So as you can see here, this is the actual shear centre of the beam. If it's loaded on this outside, it'll tend to twist sideways. Okay, and so this is a typical example of a girder bottom chord. You can see the shear centre here. The bracket's fixed on the outside, and the incoming truss is loading this bracket on the outside of this point here. So there's a tendency for it to twist, and as it twists, this bracket will tip down, and it'll affect your ceiling lines. Okay, so I've seen this measurement from this point here out to there. It can be up to 5 to 10 mil. So as you try to run your plasterboard over these sections, you'll get these dips and runs over your ceiling lines. Okay, so you can see some side examples of this happening in action. And here's the reason why. If you don't fix these bolts and brackets on the incoming trusses before the roof's loaded, then the girder will tend to twist. Okay, so a lot of people just drop these things in here, fix the bolts onto the girder part, but don't fix the fixings on the incoming truss. Okay, and that's a real mistake. Okay, so again, the more highly loaded the truss is, the more critical it is to make sure that these bolts on the incoming trusses are actually fixed, because what happens is, as this load comes on and tries to twist this bottom chord, these bolts and fixings lock that bracket in place, so the bottom chord of the girder can't move. Okay, if we go back to this previous slide, you can see this little tab underneath the bottom chord of the girder. That's also to assist to stop that bottom chord from pulling away from the incoming truss, but you have to fix these incoming truss fixings before the roof is loaded. Okay, so if you can't do that for whatever reason, make sure they're propped, put a prop under them, keep the bracket straight. If you have to load the roof, then come back at a later stage and make sure again you put these fixings in before you remove the prop. Impact drivers, they're becoming more and more powerful these days. You need to be careful that you don't go crazy with overdriving the screws. They can strip the heads off on the the boot fixings. Okay, so just be really careful when you're driving these things home that you don't just keep ratcheting them up as they reach the home point on the bracket. They can just snap off, and then the structural connection becomes compromised. Truss installation. This is always a common one. Trusses are really highly stiff structural members, but they're also very slender, and so they require careful attention to the set out of them, making sure they're straight, plumb, and there's no bows in the cords as well. So those need to be really carefully addressed on site. The AS4440 addresses most of these issues with tolerance allowances for bow and out of plumb, so you need to stick well within those limits. Site storage, another common problem. If you haven't got them, enough gluts and support points along the truss, they can bow out of plane, and the end result is that some of these plates can break while they're, again, highly stiff in the vertical direction. They're not very stiff in the outer plane direction, so someone stepping on them can easily break these plates, and they have to be sent through to us for rectification. If you see any of those sorts of things on site, make sure you contact the fabricator and get them to source a rectification details. So any sort of things like this where the plates haven't been fully pressed home as well, those are the sorts of things you need to just keep a watchful eye out for on site. And site storage, yeah, there's there's been one or two collapses that we've had to go to, unfortunately, that's resulted from floor trusses being overloaded with material prior to or during the installation phase. And so, yeah, you have to be really, really careful with overloading these particular units. They're designed for residential flooring loads, which are 150 kilos a square metre. If you go and chuck, too many sheets of plasterboard or particle board or brickwork or any of those sorts of things on these floor systems, they might not be capable of taking those loads. So you have to be really cautious. In our floor truss specification guide, we set out allowances, but it's limited to around about 300 mil of plasterboard, okay? But it depends on the type of material and how heavy it is. But you can see here there's around about 900 mil to a metre of plasterboard on here. The call from site was the floor trusses were deflecting. Went measured, they were deflecting. They were deflecting by about 15 or 20 mil. And yeah, walked upstairs and that was the result. So there's a whole heap of plasterboard. So they had to immediately get those off the floor and stack them in the other rooms. Batten fixing, another really critical issue is trusses have got high buckling loads in the cords. And these buckling restraints are provided by the battens. So generally not enough attention is paid to these on site, but it's a real critical element in the design and support of trusses. So you have to make sure they're fixed adequately. And even for truncated girders, okay, so the truncated girders rely on the jack trusses for their support. So you can see here, the jack truss is passing over, the horizontal top cord on the girder carries a lot of compression load and it's buckling sideways. Okay, you can see here, there's one fixing on these battens, one nail fixing, and what's happened is the loads on this girder has caused it to shear those nails off. What you should be doing is fixing to each one of those laminates on each one of those battens. Okay, so 3 nails on those battens across those triple girder. And again here, this one they just haven't put any nails in whatsoever. And so the girder truss has got loaded and then buckled sideways and nearly collapsed. Thankfully, it got caught before it catastrophically collapsed. So batten fixing, again, 4440 is the governing document to refer to for batten fixing. Got to fix it to every ply of multiple girder trusses. No more than 1 in 3 battens spliced on any particular truss cord, and no 2 splices that will be adjacent on any truss top cord. And critical one, no splices are allowed on the girder. So you've got to fix to every ply on the girder, and you're not allowed to have splices running over the girders. Another common one, we get lots of inquiries about your truss. The trusses are deflecting. Trusses are really stiff. Okay, so carrying roof tile loads of up to half a ton over 5 to 10 metres, they may deflect 5 or 6 mils. So if you get a call from site saying your trusses deflected 20, there's either something structurally wrong or some of the slab levels are potentially out. So what tends to happen is people look at visual keys on site, but the best way to address these things is to measure them and measure them accurately. Okay, so this is a typical example. A truss will be, one support wall will be say 0 mil here, on the other wall it'll be 20 mil down. People look at the internal wall and see this lack of clearance over the internal wall and assume it's the truss deflecting, but generally it's this support height variance from external wall to external wall. Okay, the trusses will just follow those. So you just have to make sure that, the slab's accurate and level before you install your trusses. The further this wall moves to the right, obviously the lower the clearance is going to be because you're getting more towards this 20 mil. Okay, so that's a real key thing to watch out for on site. And these sorts of issues are common as well. The return walls, so the side walls and the height on those versus the front wall. What tends to happen is the girder truss will run along this lower level, and it may also deflect, 5 or 6 mil. And so at this point where the jack trusses are running out to the girder, it's actually running downhill. So this front wall, because it's higher than these side walls, what tends to happen is the bottom chord of the jack will run down on the slope. And so the cornice line will obviously follow that. And you can imagine if you've got a doorway or an entryway here with a level architrave, the eye tends to pick that up. The cornice line and the architrave running on skew. So just be really cautious about that. If you see those sorts of things, the best thing to do is either to measure this truss and make sure that it's straight, or level the walls at these 2 points and just make sure that they're within tolerance. And correctly measuring trusses, we get a lot of calls saying, the trusses have gone 10, 15 mil, but it's usually that one truss has gone 5, and then if people are using spirit levels, it actually projects this deflection down to the next truss. So if you run your spirit level from this one, say this is 5 mil out below this one, the spirit level actually projects it down to 10 mil on the next truss, even though this truss is level. Okay, so you need to be really careful when you're taking measurements on site that you're measuring accurately. Spirit levels are a no-no for me. They just don't give any sort of accurate readings. The best way to measure a truss is along its span length. String line's a suitable method. So if you pin a string line and make sure it's taut between the truss heels, that'll give you a good indication of how much deflection is actually in that truss. And the other one's obviously the best methods we use, electronic water level, which is fantastic, and laser level. So those are the two sort of preferred methods. String line is a good sort of rule of thumb to see what sort of shape you're in. But yeah, spirit levels are definitely a no-no. And that's it for today's presentation. Questions?
Very good, thank you, Ian. You pack a lot of problems into 20 odd minutes, and hopefully you solved some for our audience today and prevented some for our audience today. We do have one question from the audience, which is, when you see these issues happen, what's the course of action to take?
Yeah, look, the common thing, if it's a structural problem, so if you see issues with nail plates and claw plates, structural issues, the best thing to do is to contact the fabricator and get them into contact with us. So any sorts of structural issues, then the mechanism is to go back to the fabricator, let them know those designs and details come through to us. We review them and then provide a remedial action for the site issues. Okay, so I mean, some of the presentation was sort of broken up into different areas. So the major structural ones are, claw plates missing, broken members on site. Those need to go back through the fabricator and come to us. The other ones were, as per the presentation, just addressing those particular fixing elements and making sure that they're addressed properly on site as you're doing the construction phase.
So of all those topics that you've brought up today, which would be the one that would make the biggest difference if we could avoid it?
Yeah, look, I think post handover, it would have been internal wall brackets would have been one of the primary ones, because they've incorrect fixing has been one of the banes of, you don't see it on site during the construction phase. You see it 12 to 18 months later, and then you have to go and crawl around a roof, pull cornice lines off. So I think, for builders and their teams, that would be probably one of the most expensive ongoing issues that I've seen. AC units is definitely a big one, because it's, so much, the whole schedule of works comes to a halt. We have to provide a rectification design, and it's really easily solved by having those plans available with the correct information during the quoting and detailing stage. it's kind of a easy fix, I think. And you know, the number of requests we get through for AC units is quite high. So that's another one I think is a real key thing to address.
Very good. Well, we don't have any other questions from the audience. So if you've seen something useful today, if you want to share it with anybody else, this will be available on our YouTube channel in a couple of days' time. So thank you everyone for attending, and we'll see you next time.
Take care. See you everyone.